There is more than one way to tie a knot to join two pieces of ropes. Similarly, in chemistry, there is more than one way to form the bonds between the atoms. Let's explore them. We have already studied that various stable compounds are formed by the sharing of electrons between atoms. These bonds, called the covalent bonds, may be single, as in the case of hydrogen, double, as in oxygen, or triple, as in nitrogen. In this topic, we will study these three different types of covalent bonds composed of the sigma and pi bonds. Let us consider two hydrogen atoms approaching each other. The imaginary line connecting the two hydrogen nuclei along which the atoms approach each other is known as the internuclear axis. We know that each of these hydrogen atoms has a single electron in a 1s orbital. As these atoms come very close to each other, their s orbitals, which are spherical in shape, overlap along the internuclear axis, thereby facilitating the sharing of electrons. Such a type of overlap of orbitals in which the shared electron pair lies on the internuclear axis is called an axial overlap, and the bond so formed is called a sigma bond. As we can see clearly, the shared electron cloud lies exactly in the center of the two nuclei, and since it is negatively charged, it is attracted simultaneously by the positively charged nuclei of both the hydrogen atoms. Also, the extent of overlap of the orbitals is quite high. This greater extent of overlap of the overlapping orbitals, as well as the strong attractive force exerted by the two nuclei, makes the bond quite strong. Now let's consider two oxygen atoms having atomic number 8, approaching each other along their internuclear axis. We know that the electronic configuration of an oxygen atom is 1s2, 2s2, 2px2, 2py1, 2pz1. Clearly, the 2py and the 2pz orbitals are half filled with one electron each. Thus, the two oxygen atoms approach each other in such an orientation that the two py orbitals face each other and eventually overlap along the internuclear axis of approach. This bond is therefore a sigma bond. Simultaneously, the half-filled 2pz orbitals of the two oxygen atoms, which lie perpendicular to the plane of the sigma bond, also come so close to each other that they overlap. However, this overlap is not along the internuclear axis but perpendicular to it. It is partly above and partly below the plane of the sigma bond. This overlap between the orbitals, which is perpendicular to the internuclear axis, is called a lateral overlap, and the bond so formed is called a pi bond. Note here that the extent of overlap between the orbitals is less in a pi bond as compared to a sigma bond. Besides, the shared electron pair in the pi bond does not lie exactly in the center of the two nuclei. Thus, the force of attraction between the shared electron pair and the nuclei is comparatively less than that in a sigma bond. Therefore, a pi bond is always weaker than a sigma bond. We can thus say that in a molecule of oxygen, the double bond consists of one sigma and one pi bond. Now, let's observe the overlap of two nitrogen atoms having an electronic configuration of 1s2, 2s2, 2px1, 2py1, 2pz1. As you can clearly see, there are 3 p electrons which need to be paired in order to form a nitrogen molecule. These atoms approach each other along the x-axis, which acts as the internuclear axis. Thus, the 2px orbital of each nitrogen atom overlaps axially to form a sigma bond between them. Simultaneously, the 2py and 2pz orbitals undergo lateral overlap between them, forming two pi bonds perpendicular to the internuclear axis. Thus, the triple bond between the two nitrogen atoms is made up of one sigma and two pi bonds. To summarize, we have studied that the axis along which two atoms approach each other is known as an internuclear axis. The covalent bond formed by the overlap of orbitals along the internuclear axis is called the sigma bond, while the bond formed by the overlap of orbitals perpendicular to the internuclear axis is called a pi bond. A single covalent bond is a sigma bond. A double covalent bond is made up of one sigma and one pi bond. A triple covalent bond is made up of one sigma and two pi bonds. Do you know about an important process which takes place during the covalent bond formation between two atoms? We will find out about it in the upcoming videos.
Keep imbibing. We believe in you.